is a problem on, obviously, as the prompt says, vectors and projectiles, where you are starting off with that you were told that the entire flight takes 5 seconds, and that you could technically say that it starts from some sort of reference height, or you can say that since it is at the reference height, that is technically at its own sort of origin of 0. And then 5 seconds later, it will return to that same origin point because it would have taken its entire flight to go up and then back down. And this whole time, for a projectile motion, the y acceleration is minus g, basically gravity pulling down, as always should. So to begin, you'll need to start with this kinematic equation, where at any time t I should note that this is a sort of delta t, where basically this is the later time and this is your initial time. Most cases start with initial time of 0, which is what this problem thankfully does. So any other later time t, if I know an initial position, why not the initial velocity in the y direction, and I know my y acceleration, after any amount of time has passed, this kinematic equation should be able to tell me that later height. So plugging in the values that we have and leaving the ones that we don't have, 0 equals 0 plus the initial y velocity that we're looking for times 5. I've left off units because you can keep them in there and shuffle them around, but it does not technically contribute to the final answer one way or another. Moving values around, so that 25 over 2 times g, you can add to the other side since there's the minus on it, and then there's 5y naught. Plugging in the values that we have for g, we can then approximate and say that the initial y velocity is about 24.53 meters per second. You can plug through the actual values to get higher significant figures if you need to. It is exactly 24.525, if you're wondering. For part B, you need to figure out what is the maximum height the rocket reaches. This can be found out by using the following kinematic equation. Your later velocity at any time t squared from an initial time, which in this case is 0, from an initial velocity at that time squared, plus 2 times whatever the y acceleration is, times the change in distance that occurred. For this part of the problem, well, first I must note that whenever you reach maximum height, this is at the point that the velocity for the smallest instant goes to 0. Basically, it stops moving for an instant up in the air, which translates mathematically that at Tmax, the time when it's at maximum height, will be 0 meters per second. So this helps in the kinematic equation because the other side goes 0 squared equals 24.53 squared from before, plus 2 times minus g times y max minus 0 from the 0 height that we were working with before. Rearranging and moving values around, you'll get 2g y max equals 601.476 meters squared per second squared. That says the meters per second dot squared. And divided by 2g, we'll simplify down to 30.66 meters that it will go up. You could have also done it where you used this equation again, the y of t equals that. You could have stated that whenever it gets to that maximum velocity, it would be at half of the total travel time, so 2.5 seconds, and you could have plugged in values there. Both ways work, and they actually do both end up getting the 30.66. You can verify this on your own calculator, but I hope this helps with working with the kinematic equations. Thank you. Have a good day.